Hello and welcome to our final video on indices laws. In this video, we'll cover indices whose powers are fractional and learn how to think of them and conceptualize them. So let's get straight into it. Here we have x to the power of a half, and I'm going to go right ahead and tell you what this is equivalent to. X to the power of a half is equivalent to the square root of x. How does that happen? Well, let's take 3 to the power of a half times 3 to the power of a half. What does that equal? Let's go ahead and apply our indices laws, which we've just learned. If you apply the first law, which states that when you have two indices multiplied together, you add the indices. One side note here, when we say two indices multiplied together, it's understood that we're talking about two indices whose variable, or number, are one and the same. So for example, three x's, each of which is raised to some power, multiplied together would work. But a to the power of 4 times b to the power of 5 wouldn't work, because the bases are not the same. Similarly, you can't do anything to 3 cubed multiplied with 4 squared to simplify them both. All you can do is calculate each of them separately and then multiply the two, so you'd get 81 times 16. Never multiply the 3 with 4 to get 12 and then use indices laws to add the powers. That's a fatal error. Back to our example. Using the first indices law, we add the two powers together and we get 1. So our answer is 3 to the power 1 or just 3. At this point we stop and ask ourselves, what other number do we know of that when multiplied exactly by itself gives 3? And the answer is root 3. Now since there can only be one number which when multiplied by itself gives 3, we can conclude that root 3 and 3 to the power of a half are actually one and the same. They are equal. Let's take a look at another example. Here we have 3 3's to the power of a third multiplied together. Using our first indices law again, we say we can add the powers together, which comes to 1, and so we get 3 to the power 1 or just 3. And then using the same reasoning we did in the last example, we can say, but the cube root of 3 when multiplied by itself twice also gives 3. Therefore, as the number which when multiplied by itself twice to give 3 must be unique, 3 to the power of a third must equal the cube root of 3. One more example, we have 5 6's each to the power of a fifth multiplied together. Adding up the powers, we get 1, so our answer is 6. Skipping the steps, we can see that the fifth root of 6 is equal to 6 to the power of a fifth. Hopefully, that was clear. But now, what happens when our powers don't add up nicely to a whole number, but instead give us a more complicated fraction? Let's take this as an example. We have 3 2 to the power of a halves multiplied together. We can add up the powers and we get 2 to the power 1 and a half, or 2 to the power 3 over 2. Now, here we can use the fact that fractions can be split up in different ways. One way is to take the numerator, separate it, and then multiply it by 1 over the denominator. If we do this, we get 3 times a half. Rewriting our indices, we get 2 to the power 3 times a half. Now why do we do this? Because now we can use another of our indices laws, which will enable us to tackle this in 2 steps. Just as we've been doing, when indices are multiplied together, we add the powers. When dividing, we subtract. But when an indice is itself raised to a power, we multiply the powers. So we can use that last part and work backwards. Instead of having an indice raised to a power as a result of which we multiply the powers, here we have an indice whose power is a product of two numbers. Thus we can work backwards and rewrite it as 2 cubed raised to the power of a half. Now you can probably see where we're going with this. If we do the bit in the bracket first, 2 cubed, we get 8. And now we raise that to the power of a half, which is just the square root of 8. And that's all there is to it. Let's take a look at one more example. 4 to the power 3 over 2. We can split the powers up into 3 times a half, then rewrite it using our indices law as 4 cubed to the power of a half. Then do the bit in the bracket first, 4 cubed to get 64, then take the square root, which is 8. One final comment before I end the video. You might be asking yourself, well, could we have done it the other way around? Instead of doing 4 cubed to the power of a half, could we have done 4 to the power of a half, all cubed? And the answer is yes, we could have. In that case, 4 to the power of a half is just the square root of 4, which is 2, and then we cube it to get 8. In most cases, however, it's much easier to leave the fractional part till the very end. And there you have it, how to deal with indices which have fractional powers. You're now ready to tackle some problems which I've linked in the video description below. The next video will go through their solutions.